Problem 3-53. Rewrite each radical below as an equivalent expression using fractional exponents. So we're going to take each of these four expressions and we're going to rewrite them as an expression with a fractional exponent to get rid of our radicals. Just a quick reminder, if we have some number, our base, and we're raising it to a power that involves an exponent, our power goes in our numerator and our root number goes in our denominator. So in this case here, when we look at the square root of 5, and remember, the square root of 5 normally doesn't have the 2 out here in front, but we're going to write it in here right now because it's a newer concept for some of us. So we have the square root of 5, and if we think about 5 right now, when it's written by itself there, is like 5 to the first power. So we take this here, if we want to get rid of our radical, we're going to say 5 to the first power is being raised to the 1/2 power. Well, 1 times 1/2, if we use our properties of exponents, when we take a power and we raise it to another power, we simply multiply. So we're looking at 5 to the 1 times 1/2 would be just 5 to the 1/2 power. Now that might seem a little odd that I'm doing that with a 1 here, but as we get into some of the other problems here, it may make more sense why I'm explaining it that way right now. So problem B, we have the cube root of 9. So if we think about it there, we've got the cube root of 9, and if we think about what power is 9 being raised to right now, it's like the first power. So we have 9 to the first power. And another way to write the cube root would be to take something and raise it to the 1/3 power. Now, using our properties of exponents again, taking a power and raising it to a power, we're going to multiply them there. So we're going to say 9 to the 1/3 power. This is the same thing as saying the cube root of 9. Part C. We have the 8th root of 17 to the power of x there. So when we look at this one, we have 17 to the power of x, and another way then we can write the 8th root is by taking it and raising it to the power of 1/8. But if we take our properties of exponents and we actually multiply these two powers together, we're going to end up with 17, and x times 1/8 would be to the x over 8th power. So that's 17. We have an x for our numerator, 8 for our denominator. I know it's a little messy there. Part D. We have 7 times the 4th root of x to the 3rd. So 7 right now is not being raised to any power except for 1. So it can just kind of hang out here by itself. And let's focus on our x here. We've got x to the 3rd power right now, and it is being raised to the 1/4 power. Remember, the 1/4 power is the same thing as taking the 4th root. Now, because we have a value here of 3, we're taking that 3, that exponent, and we're raising it to another power. So we're going to multiply those together, and we're going to end up right now with 7 times x raised to the power of 3 times 1/4 is 3/4. And if we're just putting it all back together here, this is like saying 7x to the 3/4 power. If you're having questions about these here, or you still aren't understanding, you need to make sure you take the time to ask your teacher in class.